Alright, time for another DraftPhysics.com video presentation. Debate physics also, and it's debating anything, right? It's what's the rules of reasonable trying of a statement or a story or anything. So I'm just saying, let's just call them stories. Everybody can tell a story about what's real. Okay, I could tell a story that there's a little hamster actually inside this guinea pig. Okay, inside this guinea pig is a little hamster, and he's making the guinea pig do what he does. Now, right now, he won't do anything because his batteries are dead. And so the hamster is stuck with a bunch of controls that aren't working because, he's trying to make it work, but there's no battery power, so he can't make the guinea pig do anything. So I could tell you a story. Now you'd say, well, let me see the pictures of how it was made. Let me see a picture. Just tell the hamster to, unzip the back or whatever and say, hi, I'm the hamster. So I'd have some expectation about what kind of evidence could be produced. And we could call that, I can even have an intuition about things that are easy to prove. So if somebody did in the modern era say there's Jesus and he walked on water, we'd all say, well, get your cell phone out and take a video of it, okay? I don't want to have to go to wherever Jesus is, right? He could be halfway across the world. Just take a videotape of him walking on water, okay? No big deal. And, of course, they could do it with mirrors, like magicians. And then I could say, well, I'd like some witnesses to be there just to make sure there's no shenanigans, no big deal. And if they resisted, or they made some excuse and said, no, well, gremlins, every time we try to pull out our camera and take a picture, the gremlins steal our cameras. And you say, what do you mean gremlins? What are you talking about? So, it's all the veracity of a story. And so that's what physics is, all right? It's a bunch of stories about how the universe functions. They can tell you a story about wormholes or black holes, and they fold pieces of paper and say, see, if you fold the piece of paper, you can go from here to there in 15 seconds. Some sort of story they're telling you about how this is a real thing, and you can, somewhere in the universe, this actually happens. And so it's really just about how we weigh evidence and how much evidence. And you can, we're all playing juror, okay? And it's whether the juror knows they're stupid, right? So I've seen lots of trials. I can bring up the OJ trial, but the one that's, to me, more egregious. Just shows how the system is so broken, it's beyond fixing, okay? This idea of juries was a General Motors case where there was a $50 billion, right? The jury said $50 billion to a kid who was killed in a crash. So it's all about physics. The whole trial was about physics. And so a drunk driver plows into a truck at 70 miles an hour, right into the side of the truck, the driver's side of the truck. And the kid is killed instantly. That's just a fact, okay? Because they proved the G-forces alone made jello out of his fucking brain. So his brain was turned to mush by the G-forces alone. And then the truck caught fire, and and this took 5 minutes. It took 5 minutes for it to catch fire. So let's understand. There was no rescue squad. It was the middle of the night, 12, 1 o'clock in the morning or something. So, so some spectators showed up once it caught fire, and so there were some witnesses to the after effect, but no witnesses to the actual fire starting. And anyway, but just insanely stupid. They had testimony about, well, there was this fluid. The witnesses saw fluid coming off the car. Yeah, it just got plowed into at 70 miles an hour. And it has it has a lot of antifreeze in it, of 7 gallons in a pickup truck. That's what was leaking out, right? It wasn't on fire. So here's a truck on fire. There's fluid leaking across the road, and they speculated. They told the story. That's the gasoline. When obviously, if it was the gasoline, it would be on fire, wouldn't it? So if the gasoline was pouring out of the truck, then there would be fire on the street where the gasoline would be going. But there wasn't any such fire. The people were standing 1 foot away from the fluid, okay, and it wasn't on fire. So, just insanely stupid. So, obviously, the jury was incapable of reasonable evaluation. And they're 12 morons. I mean, all 12 of them had to agree on this theory that somehow the fire killed the kid. No smoke in his lungs, all right? And they proved the G-forces would kill him. They had the absolute velocity of the collision because the other guy's truck was a modern truck, and it had an electronic speedometer. And the speedometer freezes when the battery dies. And it froze at 70 miles an hour. So the truck could have been going faster, but it couldn't have been going any slower than 70 miles an hour. Plows right into the intersection. And they blame General Motors. They say General Motors made a shitty truck because somehow it didn't survive a 70 mile an hour crash. I mean, that was how stupid this was. And it's a 30-year-old truck. It's General Motors' fault because a 30-year-old truck couldn't get hit at 70 miles an hour. I mean, too stupid. All right, so I'll use that as a preface to this moronic conversation about some sort of intuition. Okay, there's nothing wrong with intuition if you disciplined it through much experience. Okay, I can have an intuition about how to lose, what pliers are going to do. I know, okay, they're not going to jump out of my hand and, poke me in the eye. I know that's not going to happen. Okay, so I have a pretty solid intuition about what can function. Now, I still, now and then, will catch my finger in them, okay? Because, I have a tendency to say, yeah, I can get away with this, and I can get away with this, and sometimes I don't get away with it. So I know there's a, 1 in 1,000 chance, okay, that when I'm trying to do something, if I'm doing this certain maneuver, there is some risk that I might get a little pinchy poo there. Okay, it might happen. So I have lots of life experience. I gain knowledge. I don't have to do a great deal of thinking. I don't have to sit here for 5 minutes before I use the pliers and say, let's see, how do you lose pliers? Don't run with pliers. Don't do this. Don't do that. I don't have to go through all that crap because I have experience. All right, and that's a good thing. It's not intrinsically negative. But we're really talking about when we have to put our suit on and sit in judgment, okay, when we're really trying something. So we're saying, yes, this is when you have to be honest and you have to do your thinking, okay? You can't just slide by on some vague notion of what should happen. So I would argue in this whole discussion about kinetic energy, if we actually went out and asked people, if I went out and randomly just picked some moron off the street and said, do you think it takes 9 times the fuel to go 3 times as fast? Or do you think it takes 3 times the fuel to go 3 times as fast? They're going to use their intuition and get the wrong answer, okay? They're not going to know, oh, there's a kinetic energy formula? Oh, it's 1/2 mv squared. Oh, I didn't know. Anyway, So it's not a subject. You really can't argue intuition when you're arguing about what should scientists believe. What should scientists assert with a level of confidence? Okay, so that's all it's really about. And should they be confident about anything or nothing? I think they can be confident that, yes, pliers will not spontaneously go nuclear and blow up a country. So I'm not risking blowing up the earth because I did this with a pair of pliers, because they just can't do the going critical thing. Can't happen. Just can't happen. Okay, it's been tried a zillion times and it's never worked. So we don't have to worry about pliers going nuclear. So we could be really confident, okay, that I can do lots of things with pliers and I don't have to worry about it reaching critical mass. So yeah, I just don't. There's no other way to argue this than to argue it through examples. And so the examples I'm going to use to this butthead, talking about intuition and how it's a problem, is what are you doing when you're evaluating the evidence of the things you believe in? He believes in all these black holes. He believes in all this crap for which we don't have any pictures of this Jesus walking on any water. We have just little shreds, little tiny, tiny bits of a foggy, it's a Sasquatch image. We have this little Sasquatch image. And, some guy, you can see the zipper in his suit. Okay, it's kind of obviously not very good evidence. That's what they have. And you're saying in context, why are you being convinced by this tiny bit of evidence when theoretically you could have the videotape, with no zipper. No, that's what you should have, is a high resolution photograph, not a low resolution photograph. You know that we have smartphones that can take a better picture. Why don't we wait for a better picture? That kind of thing. And they don't do it. So I brought up the Eddington experiment, which is just so obvious that, well, what are we supposed to believe? There's 400 times better resolution from space. You don't need an eclipse to do the sun, and you can also use Jupiter and still have 300 times better resolution. Huge advantages. It only takes 5 minutes. And again, you could use a 50 times inferior telescope and you still have 250 times better resolution. It's so much better from space, and it's such a clear example. It's an imaging of the actual effect of photons, image photons being deflected by, the only thing they could be deflected by is the gravity, because particles would scatter the light and there wouldn't be any image. But if you can make an image move, then you've proven it's some other force that caused the deflection. It can't be scatter, because you moved the whole image and it all moved coherently. So it would have to be a coherent force that bent it. So it's really important to have image data bent by gravity. Now that's a little bit, you have to know a little bit about physics to realize there's a difference between, radio scatter or some signal that's just in the form of scatter and an image. That those are two different levels of proof or evidence. So what are you supposed to believe? All this time, NASA never even tried it. It takes 5 minutes. Any old bullshit camera will do. 5 minutes. And they never even tried it? Yeah, no, the real story is they casually did it, tried it, it didn't work, and they just ran the hell away from it. Just as they run away from informing everybody that kinetic energy didn't land on the moon. Okay, the kinetic energy theory didn't land the lunar module on the moon. Okay, momentum did. All right, so these are all arguments you could be made, right? So I can go all the way back to Leibniz's claim. So here's a physicist. Your theory is based on, your theory was initiated by a man who said, okay, dropping 4 pounds 1 foot is the same energy, hits the ground, as dropping 1 pound 4 feet. That's what he claimed to be true. Okay, now clearly the lever says that can't be possible, because the lever's a balance, and that balance will say those two things won't balance. Twice the velocity and one mass will not balance with 4 times the mass at one velocity. Those things will not balance. Fact. So it's premised on a false axiom, a false premise. Antifreeze is gasoline. It's a fake premise. It's not gasoline pouring out of the truck. It's obviously antifreeze pouring out of the truck. These are the facts, okay, that somehow you're going to distort to find some reason to convict, right? And that's all we're saying here. This is a disgustingly bad trial. You're a shyster lawyers defending nonsense theories with vacuous evidence, non-existent evidence, and then you'll claim you detected a photon in the two slit experiment. Oh, we put the detectors on, and all of a sudden the pattern disappeared. You didn't turn on any detectors. There's no detector experiment. It's an absolute made-up fable. And here he's talking about intuition. Intuition isn't the problem. Any kind of fair-minded judgment of the facts is the problem. You're all clearly insanely bigoted, and you're just trying to support nonsense theories that you personally like because they're fun. This isn't about evidence. It isn't about anything. I mean, he says intuition isn't evidence. Of course it's not evidence. That's your judgment, and you're saying, can I use intuition to make a judgment? Well, if the theory the lawyer's going to say is the pliers jumped out of the man's hand on their own and stabbed the other guy in the eye, that's his theory, then my intuition says there's no reason for me to say this is possible until you show me that videotape of the pliers jumping out of his hand and flying into the other guy's eye. okay, and into his brain. So I can use my intuition to know pliers can't do this. Okay, there are no gremlins, there is no magic, there is no blah blah blah. And until you show me, I should have no reason to believe it's possible until you show me some evidence that it actually happens. And that's the part where, you know, they're just playing these games. So we know the kinetic energy theory says, you know, I'll just go through it again. You know, 4 times the fuel to go twice as fast, 9 times the fuel to go 3 times as fast, 16 times the fuel to go 4 times as fast, 25 times the fuel to go 5 times as fast, and the same is the reverse. If I go 5 times faster, I do 25 times the damage to something. They have zero evidence of this, okay? So in 300 years, they have compiled no evidence that any of that is true. There's not a single experiment showing 4 times the energy going in and twice the velocity coming out anywhere. So they don't have this experiment. They don't have this evidence. Well, the more important one would be the 9 times to go 3 times as fast, or the 16 times to go 4 times as fast. Obviously, none of this exists as evidence. And but they just keep making the claims, and I can make all these arguments about how it doesn't work in space. Like I said, if you calculated the lunar module going down to the moon's surface, and if you use kinetic energy theory to judge how much energy your particles that you're shooting out to use as thrust, if you use gases usually, how much air, you know, compressed air, whatever it was, how much you used based on the velocity squared, you would get wrong answers about how much energy you imposed on the lunar module and how much you changed its direction. So the fact is, it won't work. I mean, these are gigantic facts in this trial, and you totally ignore them and talk about somebody shouldn't use intuition. I would argue that, yes, if you have time to think about anything you're doing, think about it first. It's always better to give it more thought than less thought. But there's nothing wrong with saying, I know for a fact there's no gremlins. Gremlins don't grab pliers out of somebody's hand and throw them into somebody's brain. It don't happen. And antifreeze doesn't burn cars. Yeah. This world is just such suck that this guy would talk this crap. So let's just go through this. Rapid intuition responses is not based on the evaluation of new evidence. So evaluation of any evidence, okay, old or new, it doesn't matter. And it has to be put in a context. And so if somebody shows up with silly evidence, when you know they could have better evidence, that is, they could take the actual videotape and they just show you a drawing. You know, so this is what there's a drawing of what I saw. Yes, I had a cell phone in my pocket, but I didn't take a picture of it. You know that evidence is garbage. Okay, so when you know there should be more evidence, then you have to take that into the context that why are you using this weak, you know, foggy evidence? Why are you using this foggy picture when you should be able to take a real picture? All right, based on prior experience and patterns we've identified. Well, the pattern we should identify is that humans suck at trying evidence. That's why most of the humans on Earth still believe in a God, is because they have an inability to frankly rationally interpret facts. They just can't do it. Okay, their brains suck. All right, I don't know, you know, whether that's an evolution thing. I don't know whether it's like whoever survived the plagues and whatever survived this, and these were all somehow, you know, more monkey than man. You know, who knows? Allows for rapid, low-effort responses to situations. So none of this is a real issue, okay? I mean, the fact is that people have all the time in the world to respond to my comments. I'm willing to pay them to respond. I'm willing to pay them to take their time to answer my questions, and they won't take my money. They won't do it. Substantial evidence that these automatic responses govern much of our thoughts and actions. So again, all of the responses are automatic. I mean, we're all determined machines. We're all calculators. And we're really just arguing, does your calculator tend to be sloppy, or does your calculator tend to be careful in terms of doing its calculations? Okay, and everybody should be saying, yes, we should be as careful as time allows. So if you're stuck with some situation where there's a fat man on the bridge and there's 7 people on the ground tied to train tracks, and you've got to make some right now decision, well, yeah, okay, you could make a mistake, in your calculation, because you're not really given any time to consider, well, maybe those 7 people are all child molesters, so maybe I'll just say, fuck it, and I don't want to have anything to do with this. Maybe I'll just go get an ice cream cone, because I don't want to have anything to do with this bullshit. I didn't sign up to make these decisions. That would probably be the right decision, right? It's just to say, fuck it. It's not my business. I didn't make the train. I didn't tie the people to the track. I didn't make the guy fat. I didn't do any of this shit. It's not my problem.
So it's in our best interest to understand a bit of when our intuition is more or less useful, and how we can...
So again, it's just insanely stupid to say based on any kind of use. I mean, it's obviously, for most of us, our intuitions are pretty solid. If we're sitting around praying to a god, okay, it's our intuition, our instinct, our impulse is to say, oh, I better pray or God will kill me in some horrible way. I better suck his, or else he'll get me. I mean, what is it? Fear? What is it? What's the exact thing that's causing the person to do this thing that's just totally counterintelligent? Okay, it's not counterintuitive. It's counterintelligent. Superstitious bullshit. And so, yeah, you're run by it. And so, obviously, in this case, the argument is you're run by some inability to make a distinction between the robe, the king's wearing, and the integrity of the king in the robe. Okay, is this a man in a suit or a suit on a man? And you can't make these distinctions. That's the problem. You can't judge the integrity of evidence.
So
you're judging its integrity based on whether it confirms what you want to believe, not based on what is it? Does it really have any integrity? Have I really proven any case?
First, we need to be looking at situations that are very regular, where we have lots of prior experience. This could be everyday situations, even things as simple as interpreting facial expression.
Pliers that jump into people's eyes. Or hamsters inside of guinea pigs.
Understanding simple sentences, catching a ball, things like that. Things that involve...
Okay, blah, blah, blah. Again, this is just such a... What the fuck is he bringing this subject up? So he really hasn't in any way engaged in any constructive way in this kinetic energy argument. I mean, he did some experiments, but they all were tainted because he used his own clay theory of inelastic collision.
Hopefully my acting abilities are good enough to be able to represent that. But you don't have to go through and think, oh, what is he doing with his brow, or what's he doing with...
Okay, who cares about this crap? I mean, I don't even know why he's going into this shit, especially when this guy has kind of a buggy look. I mean, you could, profiles in serial killer. I mean, it's not a great mugshot. He wouldn't make a great mugshot. Now, obviously, I would also, I mean, I'm going to come out looking like an old drunk, metal band guy. What the hell happened? I didn't turn this video off.
Expression for less than a second.
Jump ahead. Who
cares? About what each one of those words mean. If you know how to read, then you're able to put those pieces of information together fairly accurately.
So this isn't anything to do with intuition, frankly. I mean, the fact that our brain makes clear associations and then can start recognizing patterns without seeing much of the pattern. I can move this very quickly, and some part of your brain will recognize it's a little blue dot inside a white dot, that it's an eyeball. It needs very little information to recognize something. So yes, that's how we get with language. We can start to read, and we don't even need to see the whole words anymore. We just need to see their size, and if there's a couple of T's in it, and all of a sudden we already know what the word is. Shithead.
To get a general picture of what's going on. And you can even look up online examples where the letters of some of the words are jumbled up.
Oh, fuck
And
this.
even though that
Okay,
sentence
well, jump
where,
in. Wait, who cares?
let's say there's an object, a ball at the top of a 2-foot ramp, something like that. And I don't know, when it rolls down the ramp, how fast is it going to be going at the bottom of the ramp? Well, if it's only 2 feet high, and I have a decent understanding of, that unit of how long a foot is, then I can probably say with...
So again, what does this have to do with intuition? So you're really saying here's a puzzle, and the person a person who's never seen these kind of puzzles before is going to have a lot of a harder time recognizing that they have to account for different kinds of forces when they're talking about anything moving, and they have to think about the normal force versus the abnormal forces and all of that kind of crap to decide, oh, okay, I get it. All right, gravity is really just the only source of energy. I'm increasing the amount of time it takes to move, so therefore I'm hitting it with more gravity over time. I'm putting more energy into the wood because I'm banging into the ramp. There's more friction. But in the end, all of that will eliminate out of the equation, and all there really will be is the height that the ball fell, and that's all that's going to tell me how much velocity it has. And instead of velocity down, it's going to have velocity sideways.
Confidence that the ball at the bottom is not going to be going at 50 miles an hour. It's also not going to be going at 0.1 miles an hour. As long as I, again, both understand...
Okay, so again, why would I even bother with making those kind of judgments? So what situation would I use this in where I'm taking the physics so unseriously? So yeah, obviously I know it's not going to go 1,000,000 miles an hour, and I know it's not going to go 0 miles an hour. It's not going to just stay on the slope and just stay there. So yeah, I can figure that much out intuitionally. But the rest of it does require thinking. If I have the more precise answer, it's going to require more thought.
Is starting to move their leg towards the ball. And again, that intuition can be trained. Another example of this would be chess masters being able to look at a chessboard mid-game.
So this is experience, and that's all it is. So again, you're just saying that people with more experience have a more reliable intuition. They, people who've read more books recognize words more. I mean, so what? What does this have to do with sitting at trial and judging evidence? Oh, that's right, nothing.
You're not going to be very good at it. Okay, when kids are first learning how to play catch, they're going to drop the ball a lot. But in each one of those instances, they're going to be training their...
So this is the big lie, that somehow physicists are well trained. So again, I go right back to Leibniz. So unwell trained, he never did the experiment. He never dropped 4 pounds from 1 foot and then 1 pound from 4 feet and saw the dent in the ground and said, yeah, it's the same thing. Never happened, of course. All right, totally stupid intuition, and that's your founding father. Okay, Deschartelet, denting clay with round objects, not penetrating the clay, not going through the clay, just denting the surface of clay with round objects. I mean, obviously we've learned this word linear. Obviously there's not going to be a linear relationship in how far the object goes into the clay, because it's not a linear surface that I'm dropping into the clay. So obviously a bullshit experiment. I mean, amazing. Okay, this is your science. This is showing your science obviously has shitty intuition, garbage intuition. I mean, come on, do I really have to go through the Eddington thing again and say, what intuition do I need? The guy admits in his journal he's getting 10% of the data quality. Instead of 10,000 stars per glass slide, he's got 1,000. 10% of the data quality of the experiment. And it's already a really difficult experiment. He's got 10% of the data quality. Come on. That deserves a New York Times headline, this experiment. He says right in his own journal, I wouldn't stake my life on these results. And yet, proof is what you utter. You're saying it's a proof. You're saying the evidence is of substantial quality and integrity, in spite of those obvious defects. I mean, it's obviously a dead dog. and you're trying to pretend, you got to prepare its dinner and it needs a ball to play with. No, it's dead.
What about when intuition is not useful?
So that's all over. I mean, again, this isn't about intuition. It's about bias. It's about that simple evil tendency of human beings to confirmation bias. They're looking for evidence to support what they want to believe and looking for evidence to attack what they don't want to be true. And that's what's really happening here, and it has nothing to do with intuition. It has to do with motivation. It has to do with the fact that they pay zero attention to the need to be disciplined that should be their science's first rule. First, do no corruption. First, be honest, okay? Don't force the evidence.
In a system on such a small scale where quantum effects become important, we don't have any intuition. We do not have any everyday experience.
So this is another bullshit statement that, of course, I can draw an electron as an object, and I can draw a proton as an object, and I can give them functions, that is, they can radiate a force, for example, and the two forces can have an opposite effect on each other, which will be exactly Model's charge. So I can certainly model it and create a completely functional bit of information that completely shows the dynamic and produces the result, just as Feynman drew mock gravity on a board, okay, and demonstrate how mock gravity, that is a particle gravity, actually does do the inverse square law and does create all of the nuance of gravity. And its defect is you have to account for a drag problem. But the drag problem isn't anything to do with solving the gravity problem. It does explain gravity. This is just such bullshit.
You know, you can go on a news network and see all sorts of predictions for what's going to happen politically, 6 months, a year.
Yeah, right. And so all this science, you can keep telling us it's going to be a quantum computer. Ain't going to happen, because the whole thing is nonsense. I'm going to jump to the right answer. I found a shortcut. I don't have to actually do any physics, and I can just jump to the end result. I can take the wormhole path, okay, and I don't have to really fly through the universe to get somewhere. I mean, it's on its face illogical, and the prohibition against it should be, again, well, show me some real evidence that there's anything called an ESP, entangled particle.
On whether or not your predictions are accurate, well, that's not enough rapid feedback to be able to train your intuition in those kinds of useful ways.
So again, this bullshit about are we training our intuition, that, you know, this is just about practice, does make you more perfect. So yes, the more experience you have guessing at answers, it would help. It can't hurt, because then you know, yeah, I gotta be really careful about how I guess, because sometimes these guesses, it can all add up, and then oops, you know, I made a mistake. I had a wrong axiom in my equation. And physics should know this vulnerability. And again, they should also recognize that, this is a really severe vulnerability, because even when we know we have bad data, that is, even when we know Franklin assigned plus and minus wrong, we don't fix it, because it's inconvenient to fix. We have 17,000 different ways of describing a unit of energy. I mean, calorie, joule, watt, you can just, on and on and on. Makes no sense. They won't fix it.
To those sorts of extremely precise measurements. Other situations where extremely rare but highly impactful events, so-called black swan events, will dominate how a system acts, those will defy our ability to make intuitive predictions.
All right, so again, and that's when they just say wave-particle duality. They make up some story about how they tested all possible explanations and found none of the explanations could possibly work. They basically said, I can't imagine the right answer, therefore there can't be a right answer. And we have to accept that the world is this funky, weird thing. Bullshit. You don't do that. You admit the truth that you haven't thought of all possible ways of arranging it where it actually works. It's like taking a Rubik's Cube, and you could mess with it until you apply some logic. You're just doing random turns. You're not going to solve it. So you do have to have some theory to solving it. And this is just about the fact that some problems are going to require you to go back a step and undo something you already believe, because what you already believe is causing you to turn it sideways, and you're just undoing any productive action you could be applying to this thing to solve it, because you keep doing something wrong. And that would be my argument about believing in kinetic energy. Now you're going to get wrong answers about how much an electron weighs, and now you're going to get wrong answers about how much energy is in an atom, and now you're going to get all kinds of wrong answers because you've accepted a piece of garbage as a modeling theory.
All of those in everyday conversations have similar meanings. Their meanings kind of blend together. But in physics, all of those terms have very, very precise definitions and very, very specific properties, and we need all of those specific terms because we want...
So this is more bullshit. So they have specific terms like superposition. Okay, superposition was used to describe gravity in the sense that all the actors add to a circumstance. Not that they are the same circumstance, not that they are superimposed on top of each other. I mean, your language is the physics, the language of science is broken, and it's broken by, again, your inability to admit that a Newton can be converted into a watt or a joule. And you'll just pretend weight can't be energy. Well, yeah, it can. Yeah, it is. I mean, it's just such more bullshit that he's arguing that there's some sort of precision in his science when the lack of precision is so obvious. You can't rely on any words they use.
But let's go one step further and look at situations where our intuition is actively detrimental.
I mean, it's really easy to make particles wave. It's really hard to make waves particle.
Is actually interfering with our ability to accurately process information. Well, one case of this would be situations where we try to take our...
I mean, pull and push. Again, another so obvious. A little tiny bit of thinking gets you to the realization that it's a push universe, that any pull I can describe, pulling on a rope, I'm pushing on the rope fibers. I am not pulling on anything. I'm pushing them. Okay, I pull on a doorknob. I'm pushing on the back of the doorknob. I mean, all the handle. I mean, it's all these things can be logically deduced and understood that, yes, this language would be silly. It would be silly to talk about pull in this universe, a pulling force, when it's an inverted push. It's always going to be something pushing something. It's a push universe. And you can just take that and that easy mistake of thinking a concept has two sides to it. Again, I've used in ethics, you could understand that I don't need to make a good if I make a bad and then I take the bad away. That's the same as a good. So I have the power of a good by just taking the bad away. I mean, this is so simple, the logical connection of understanding that I don't need dualities and I don't need all of this crap, because frankly the inverse is made out of the absence. Absence is the inverse. You don't need an opposite. You just need absence. I mean, even the exchange of energy and thinking of it like currency, and that something gives away its energy. It doesn't hit it with its energy. It actually gives it away. So it doesn't have it anymore. I have $10. I give away $5. I only have $5 left. I mean, it's that simple. There's no equal and opposite reaction that makes me poorer. I'm already poorer when I gave away the $5.
And that's going to literally interfere with our ability to analyze systems. Another example would be, let's say I consider a system. Let's say we've got a bar that's on a pivot, and there are some forces being applied to this thing. Well, if the system is static, we can say, well, the forces and the torques that are being caused by those forces have to balance out. So if I have some forces pushing down over here and down at a different location over here, we can talk about how the forces that are applied and where...
So again, but the way you talk about these forces is because you don't even understand them as forces. So again, you don't even get the idea that, again, it's about how long something is in the force free to move. And that every single time you touch it, you drain whatever force it has. That's the difference between free fall. Free fall isn't about hitting the ground. Free fall is about hitting anything at all, touching anything at all that's material. If you touch it at all, you're going to lose a portion of your energy. You're going to lose what you're gaining from the force. It's going to go into, like electricity, it's going to drain out of you and drain into the other object.
Where those forces are being applied, how far from the pivot point those forces are acting, those should be balanced in such a way that this bar does not move. It's the static case. But if I have some forces that are acting on this bar and this bar is starting to rotate, we're going through some angular acceleration.
All right, so now he's still talking about angular acceleration when it has nothing to do with angular acceleration as long as I have the pivot point above the bar. It won't spin.
Then all of those things that we learned about the static case, those are not going to apply to the case where this thing is actually moving dynamically, where its motion is changing, it's accelerating. So again, it's the problem of taking intuition developed for one set of circumstances and trying to apply it to another where those rules just do not apply. Another problem.
Okay, look, and yeah, we went through these arguments. Those are just the details you have to learn. Okay, that a stick held at the top. Okay, the stick where I put a little loop on the top here, and that's what it swings on. And then a stick with a fulcrum below, two different experiments. Completely different behavior. In one case, it's all or nothing. And in one case, it will oscillate.
Problem tends to occur when we take our intuition developed in a certain domain and try to extrapolate that intuition into other domains.
So whatever, again, who's he talking to? Who's the accusation towards? Because again, the whole point is that where is the evidence that conventional science has paid any attention to this whatsoever? That their argument should have deep integrity, that they should have substantial evidence. Where is there any evidence that your science cares at all about evidence? Just such bullshit.
The globe. But again, our intuition on when we feel like we're moving is based on things like, oh, am I moving along the ground quickly, or am I running and I can feel the wind hitting me, or something like that. But if us, the ground, the air around us, if all of that is rotating in the same way, is moving in the same way with very low accelerations, well, we're not going to be able to...
Even with high accelerations, we're not going to, because if we're being accelerated by the force itself. So again, gravity can accelerate you at any speed. It can accelerate you to insanely fast speeds, and you will feel none of it, because it moves every single piece of you at the same amount. It gives the appropriate amount of force to every material clump of you. And because it's all the same stuff, it's actually pushing electrons and protons. So the mass over here is the same as the mass over here, the same as any mass. It's made out of electrons and protons. That's what's being pushed. They're all the same mass. They're all the same wind sail size. Okay, they catch exactly the same amount of wind. So that's why everything falls based on how much sail it has, how much mass it has. It collects more force, more mass, and it takes more force to move more mass. So it ends up being perfectly consistent with the idea that the heavy thing's collecting more force and the light thing is collecting less force. And you can see that when they hit the ground. The hammer hits the ground, it makes a big dent. The feather hits the ground, it doesn't do shit.
Detect using our own senses those very, very subtle effects. But we can detect those with accurate measurement devices, and again, verify that the Earth is in fact an oblate spheroid. Another huge problem with intuition comes from the fact that our past experiences come with many different types of bias. These will influence our perception.
Yeah, well, again, and so he just brought up oblique spheroid and all this kind of stuff, and this has always been a problem too, though. You still haven't solved these problems. I mean, there's still arguments about exactly how the moon creates the tides. You know, whether it's pulling from the north and south poles, essentially, and pulling, okay, the water from the north and south, not the east and west.
Perceptions and interpretations of those past experiences, resulting in our intuition being trained on falsely identified patterns. This includes many of the negative things that we think about when we hear the word prejudice, but also includes many other types of cognitive bias. Things like confirmation bias, recall bias, anchoring biases, framing effects, observational biases, and...
So what do we need all these words for a bias? Okay, that is a preference. You're applying. You're desiring your client to be innocent, and therefore you're contriving ways to shenanigan your client out of the evidence. All right, you're trying to destroy evidence that's credible, and you're trying to make evidence out of things that are incredible. So at the OJ trial, there was actually testimony about the fact that there were other footprints on the sidewalk, okay, besides the 14 Bruno Malleys. And the fact is, they were footprints in the cement. Somebody stepped on the cement before it had dried. Obviously, those footprints couldn't have any credibility. Yet the lawyers were allowed to produce this testimony. They were allowed to suggest this idea when it's impossible that it could have any meaning at all. The cement wasn't wet. I mean, it's, you know, the shenanigans and the bullshit. And that's all this is. The argument is are you people doing science, or are you doing aggressive defense of a theology? You have a belief, okay, and it's marginally evidenced. Okay, you have one, you know, witness who wears glasses who says he looked kind of like him. Yeah, he was almost that same height and almost the same weight. Yeah. He had 2 legs and 2 arms. Yeah, he's pretty close to looking like a human. That's your testimony. Oh, it's pretty lame to sit there and say, okay, look, that guy has 2 arms and 2 legs, so therefore he must be guilty. That's happened at trials too. You know, these people are so ignorant of DNA evidence and all this stuff, and they don't realize that, you know, there's all kinds of, like, you can blood type somebody, and that doesn't mean shit. I mean, that's 1 in 200 people kind of thing. Or you can have DNA evidence, and it's 1 in 2 million people thing. You know, huge difference.
Many other types of bias can all affect the supposed patterns that our intuition is being trained on. Consider a simple experiment of me holding up a mass by a string. I've got mass attached to a string, and I'm just holding it up. As I hold it, I know from past experience that eventually I'm going to start to get tired.
So you should know from your physics that there's no reason for you to get tired because there's 0 energy being expended. That's what your theory says. Your theory says you are not using any energy. And clearly it's a stupid theory. And instead of saying, yes, our scientific theory has a big gaping flaw in it because we're waiting for a distance to happen. and we're not recognizing the time is happening. Gravity is working on it every millisecond. It's pushing, trying to accelerate that thing. Every millisecond. Push. Yes, it's not going anywhere. It's not traveling anywhere, but it's being pushed on every millisecond. That mass is collecting the gravitational wind. And your theory of reality doesn't recognize that at all. Doesn't say it exists because there's no distance. No distance, no energy.
When I start getting warmer, my muscles will eventually start to shake if I'm holding this for long enough. I'm clearly exerting effort and using up...
Hilarious that he brings this up. You know, when his own physics, his Professor Lewin will sit there holding his briefcase saying, I'm not doing any work. Our theory says so.
Chemical energy in my muscles. So my intuition tells me that I must be doing work on this mass when I'm just holding it still.
So he thinks your intuition, the fact that you're feeling the work, should be explaining the subject to you, when of course you should understand the subject. And the subject is the gravitational force is constant. It never stops. All matter is being pushed. The matter already on the ground is still being pushed into the earth. There's still a force pushing it back up again, restoring it to its position. Everything is doing that all the time. That should be your intuition, should be the general simple knowledge that the pushing never stops, and the only thing that can stop something from moving is something has to be in its goddamn way, pushing the opposite way.
This is a common misconception. The physics definition of work done on an object by...
So he's actually going to defend the moronic theory. The moronic theory that is not accurate, that's complete bullshit, that you are actually having to do work. You're doing work on the object to keep it in that position. It won't be in that position if you stop doing work on that string. If you stop holding that string, you stop doing counter work against the work gravity did to the mass, okay, the result is going to be obvious. You are doing work. It's just absolute bullshit that he would defend a theory that states he's not doing work. It's just so stupid.
A force is the magnitude of that force multiplied by the distance the object moves along the direction.
So again, it's just too fucking stupid. Gravity is a time-dependent force. I mean, it's obviously time dependent. I've drawn the damn drawings over and over again. There's no way to escape the time dependence. How long you are in a paint sprayer decides how much paint gets on you. There's paint spraying out of the camera. I move my hand across that field. The faster I move my hand, the less paint hits it. It's because it's about how much time it's exposed to the force. Oh, I mean, it's just so bad that he would defend this nonsense, this huge, gigantic error in their physics. I mean, it's a gigantic, glaring error that they think measuring distance is how you measure how much force affects something, when every single force is moving at the speed of light. The longer you are exposed to those things moving the speed of light, that stuff moving the speed of light, the longer you're in that field, the more that field's going to affect you. It's about the time. Oh, God damn, I can't believe he's defending this.
Of that force. And this tells us that if the object doesn't move, then there is no work being done on the mass. No energy is...
All right, so it's just so fucking stupid. First, you don't use intuition to understand gravity, and second, it's physically inaccurate. It's completely inaccurate for him to say his finger connected to his whole body is not constantly working to keep that mass from falling. It's constantly working.
Being transferred to this mass by that particular force. And we can verify this by adding in a support structure. So let's say I have this support structure right here, and instead of me holding up the mass, I'm going to hang this mass from that support structure. So the mass is now hanging from the support structure.
And what do you think is in the metal now? A bunch of eddy currents, perhaps? A bunch of tension? A bunch of molecules that are now changed in how much contact they have with each other? That the stiffness of the atoms, the whole arrangement of that bar has now been just like your arm is doing work. There's work traveling through that bar, and the base of that bar is now pushing harder on the ground. It's doing more work on the ground. So put a scale underneath your piece of crap, and you'll see the scale show you the fact that more work has to be done. The ground has to push harder back up because there's more stuff pushing down. I mean, just too stupid.
However, using this support point, we can see that as far as the string and the hanging mass are concerned, nothing is changing with this system. Nothing is heating up or undergoing.
So that's just a lie, I'd say. Did you measure the temperature before and after? Did you measure to see that you haven't changed the molecular structure in any way whatsoever, that no part of the metal, especially the T-bar part, that there isn't a place at that joint that's got a little bit hotter? Did you do any experiments to prove that you aren't creating tension in all of that metal that's transferring the weight to the ground? The signal of that weight is being transferred through the metal into the ground. The weight might as well be sitting right on top of the metal. It's pushing it into the ground. All of those atoms are being compressed by that mass.
Any discernible energy transfer. And again, this, as far as the hanging mass and the string are concerned, this is indistinguishable from whether the object is being supported from the support point or whether I'm holding this thing up. So in both cases, there's no work being done.
Okay, it's just silly to say there's no work being done when you know the ground is absorbing the energy. It's just silly to say. There's no extra energy going through this metal, even though now it weighs more. It's pushing harder on the ground, yet there's no more energy going through it. Bullshit. Absolute bullshit.
On the mass itself. And I think there are 2 points with this particular problem where our intuition fails us. First, we tend to mix up the terms force and work. When I hold up this object myself...
It's just idiotic, okay? You have to use a force to do something called work. And if work is being done, there has to be a force involved. So, I mean, again, it's just too ridiculous. It's the same fucking thing. Work is weight. Weight is force. Force is momentum. It's all the same. Heat is work. It's just scattered. We call something work because it makes something go in the direction we want it to go in. So it's just like the light bulb versus the laser beam. Yeah, it's really nice when you can get all the heat to go in one direction. Then it's a lot more useful than when it's scattered all over the place. So heat radiating from something in all directions is not very useful energy. I can't tap it in some way because it's going every way. But if I can get it to go in one direction, then I can tap it. Then I can stick my finger in it.
I'm definitely applying a force to the object, but I'm not necessarily doing work on it. And our...
just too silly, right? So he's saying we should go with some insane bullshit theory instead of the reasonable deduction that it's got to be more work. If something has to push back more, then you must have done more work to push in. If it has to push more back, you obviously had to do more work in. I mean, he's saying that intuition is fooling us. Yeah, I know. We see who's the fool. I mean, I can't believe he used this example. I just can't believe he's using this terrible mistake of physics. This is as egregious as getting plus and minus wrong. This is a huge mistake to argue in defense of it has to be moving for it to be work. I mean, we already know that all this stuff vibrates all the time, that every single piece of matter has all kinds of motion in it, and it's back and forth, and we don't see the back and forth. So every time we don't see the back and forth, that means there's no back and forth? No, we can know that little tiny back and forths are invisible, but they're still real energy. And especially if they're going insanely fast, then they could be a lot of energy. It's a lot of momentum when it's going really, really fast back and forth. A lot of energy.
Intuitive processes are not fine-tuned enough to make these two distinctions. Second, when I hold...
It's just so stupid. It's like looking at a tuning fork, right? In real time, you might not, at a high frequency, you're not going to see it moving at all. It's, it's making sound, so it must be moving. So why pretend it's not doing any work, even though I hear the sound?
This object in the air, the muscle fibers in my arm are generating a force when nerve signals cause those muscle fibers to twitch. And that process requires chemical energy. Even when I'm holding the object steady, those muscle fibers are still maintaining that tension by continually using chemical energy to go through those.
And so are on the atomic scale. So even if I put the weight on my head and use my spinal cord to make a direct route, I use my skeletal structure to carry the weight, it's still affecting my skeletal substructure. It still has to pass through. It's compressing it. Like if I put a weight on my head and did it every day, I would start getting shorter and shorter. Okay, not only just because of cartilage, but eventually I'm going to start pushing on the bones themselves. And the bones themselves are going to get fatter and thinner. I mean, they're going to get thicker in one direction and thinner in the other direction. I'm going to compress my skull, my skeleton. What, there's no doubts about this. I just can't. Shit. Things are really a lost cause when they're sitting defending something that's so fucking stupid that because we don't see the movement, it doesn't exist. When something is sitting in gravity, it's sitting here in gravity, right? It's right on the earth. We don't see it moving, but it has to be moving because the earth keeps pushing it up. It doesn't stop pushing it up. It keeps doing it. And your own ass is telling you that truth. If you're sitting in a chair right now, your ass is telling you, hey, this keeps happening. The longer I sit in the chair, it doesn't stop happening. There's no point where all of a sudden my ass says there's no pressure. I don't have to do any work. It seems to be doing work constantly for as long as I'm sitting in the fucking chair. And he calls that intuition. That's a mistake. You've been fooled by your intuition. Oh, god damn.
Twitch motions. And our intuition is generally only attuned to the fact that our muscles are getting tired, regardless of whether or not any of that energy that's being used is actually being transferred to this object. So
it's obviously being transferred. If I put you on a scale, you will weigh more, meaning it obviously is being transferred right through your body into the ground. It's obviously being transferred.
We get this common misconception based on our biased experience of how our muscles actually work.
I can't believe it. Can you believe it? I mean, I'm sitting here, he's defending the wrong assignment of plus and minus. He's defending a piece of physics that was just stupid. They should have never said it. They always should have put it in some other terminology, like it's not work you can see. It's not motion that you can see, but there's really motion. Okay, the fact that they won't even concede that we are right now bouncing in gravity. We're bouncing. You're bouncing in the gravity or going into the ground. The ground can't push you back until you go into it. You have to make contact with it. You have to hit it for it to need to push you back. It doesn't need to push you back unless you trespass. You have to push into its rubber band for its rubber band to push you back. I mean, to not recognize something so fucking obvious. is just to sit there and call antifreeze gasoline. It's just so ignorant. It's so fucking ignorant. And he's talking as a fucking doctorate in physics, and this is the best he can do?
Another different example that I think falls into this category of when biases are present in past experiences is when I've seen students doing work on homework questions, where after completing some of the easier introductory questions, say something like calculating average velocity from how far an object travels in a certain amount of time. Average velocity is just the displacement divided by that change in time. Some students seem to fall into the pattern of saying, oh, if I'm just given two numbers in the original question, then the answer is going to be what I get when I take one of them divided by the other, or maybe multiplying them together, or maybe adding them in some way. Using one of these operations will probably get me the answer. And I really try to point out to my students that this approach of just trying to guess which mathematical...
Amazing. And so this is coming from a physicist who can't really figure out that because you say per second, that is, it could happen multiple seconds, that you shouldn't notate that by squaring a number. Velocity per second shouldn't be notated as velocity squared, because the two things aren't the same thing. Any number of seconds isn't velocity squared.
Mathematical operation is going to get you an answer. That's not a good approach. That intuition of saying, oh, I just have to combine the numbers in these particular ways, that's not going to be reliable. Where instead what you should be doing is looking at physical principle.
Yeah, there's no physical principle. There's just memorized formulas. So get real. Nobody in physics understands any of these formulas, frankly. 50%, let's just say. 50% of the formulas, there's no understanding. There's just memorizing when you're supposed to use them. So you memorize the trigger word, okay, that goes with the formula, and then you say, oh, okay, this is where I apply this bullshit formula. And that's all they're doing. They're not understanding the process at all.
Are going to be applied to the situation described in the question. And should I be using the equations from kinematics describing motion?
Exactly. So how could they understand anything when they don't even understand what motion is? So again, I'll argue from, what I would argue is that the model I described better fits the evidence that exists. That force doesn't bang into stuff and then the force stops and the stuff goes. That's not how it works. The force has to continually push matter. It has to be possessed by the matter for the matter to continue to move. And the simple point is if something, some collection of objects moving, has a bias, there's more fish in a school of fish that are physically going in a direction, then the whole school will migrate in that direction. If there's more momentum, if you add up the momentum of each fish and its vector, if there's more momentum going in one direction than the other direction, then the whole school will be moving in that direction of which there's more momentum. The energy is real, and it is possessed by the objects moving. And they can't even get that right.
Should I be using the principles of Newton's laws or conservation?
So again, and they lie about what Newton's laws are. So again, they're saying that Newton's law says 1/2 mv squared. That's not Newton's theory. It's not Newton's physics. It's complete physics that he was hostile to and argued against. He didn't believe 4 pounds dropping 1 foot is the same as 1 pound dropping 4 feet. Newton didn't believe that. And yet you lie about his science, the good science he did, and pretend to put your crap on top of it and say it has Newton's seal of approval. It doesn't have Newton's seal of approval. You're just overtly lying about the evidence, frankly. You have just no integrity to be talking about intuition when you're so fucking dishonest. Newton didn't say per second. Newton didn't say v squared.
Of energy or conservation of momentum. Starting from those principles and developing the intuition to know that what I want to start with is one of those key physical principles. That's a much more reliable way of being able to get started on some of these physics questions. Another issue with using intuition is when your intuition interferes with your ability to analyze new data. This is related to things like confirmation bias, belief persistence.
I mean, this is exactly what physics is guilty of. This desperate wish to resurrect and keep alive completely silly theories. And that's all they keep doing. They keep pushing this entanglement crap when it obviously isn't working. It ain't happening. Oh, God. Let's just get this done.
To
Despicable.
accurately predict the outcomes of an experiment or not. That requirement on testability and predictability tries to take out all of those parts.
Right, and so where's the test? Again, they haven't redone the Eddington experiment. They haven't taken image data and bent it with gravity. They don't have that experiment, yet they claim it happens. They haven't shown me it taking 25 times the fuel to go 5 times faster. They haven't shown me something going 5 times faster doing 25 times the damage. So none of this. They have proven none of it. They have no credible evidence for any of it. It's just storytelling. It's just fables. It's just a religion.
So how can we better use our intuition? Well, a good first point is to recognize that intuition, again, is not evidence. Intuition is just...
Oh, boring, stupid statement. Of course it's not. Your judgment isn't evidence. Good judgment, okay, that is careful judgment, okay, is preferable to sloppy, lazy judgment. Always preferable. Oh, God damn.
And the same kind of problems that we have with intuition. We also want to recognize that intuition, while it can be helpful in checking to make sure answers seem reasonable, maybe it raises some red flags on things that we want to check, this is only going to be useful in cases where we have lots of experience and where that previous experience has had...
So what previous experience do you have with it taking 25 times the fuel to go 5 times as fast? Where's your previous experiment? Where's your previous experience? Where have you been demonstrated that this is a phenomenon? That the faster something goes, the more work it can do. Where is your previous experience? Where's your evidence? Where's your data? That's right. You don't have any.
Instead of having your intuition jump to a conclusion, try to train your intuition to prompt your mind to intentionally reflect.
Yeah, try to get your hamster to tell your gerbil what to do. No, you have to have a principle. The simple principle is more thinking, generally better. That's just the fact, okay? Sometimes it doesn't work, like a seatbelt. Sometimes it'll get you killed. But most of the time, it's going to save you, not kill you. So that's the point. You go with the probability. The probability is more thought is going to get you a better answer. Do more thinking, less reacting. But it's not going to fix you being compulsive liars. Okay? I mean, look, the fact that I've outed you on Leibniz versus Newton, you're not Newtonians. You're Leibnizians. You won't even call yourself what the fuck you really are. You're Leibnizian. Okay? You believe in Leibnizian mechanics. All right? So out yourselves. Be at least honest about who the fuck you are. Why are you pretending to be Muslims when you're Catholics?
That your intuition first came up with, or was that analysis, whatever analysis you did, was that reliable?
Yeah, well, whatever. Was it credible? Does it really stand up as being an important piece of evidence? Okay, you have evidence. You have a piece of blue fiber that can come from just about every, it has the same dye that's in 1 million different products. And so you have a little tiny bit of blue fiber. And that guy just happens to have a blue rug that has that blue dye fiber in it. or you have a gun with fingerprints. I mean, obviously these are different kinds of evidence, all right? And you don't sit there and pretend that the blue fiber is all I need to convict him. That's all. That's the proof. We've proven it because I have a blue fiber. No, not even close. All right, so enough. What an asshole. Fuck, I can't believe he defended the "it's not moving, therefore it's not doing any work. So it doesn't matter how fast it goes back and forth or how tiny the little back and forth motion is, it's not doing any work. Tiny motions don't mean anything." Too stupid. And just the idea that obviously you shouldn't be thinking about its motion. You should be thinking about the force. And you already know it's a constant force. You already know that. Every single experiment says the force never goes away. It never stops. It never, ever, ever stops being a differential. There's red on one side and blue on the other side. There's no way you can ever change that. It's always red on one side and blue on the other side. There's always a conflict. And so you're always, when you're in gravity, you're always moving. Whether you can see it or not, you're doing it. All right, till the next time, and such and so forth and whatnot. God damn it. I mean, I can't think of a dumber thing for him to defend. I mean, like I said, he could go to plus and minus and say there's some sort of logic for assigning these things the way they're assigned, when obviously it's an excess of electrons that causes the potential differences, the voltage. And obviously the assignment is backwards. You know, why would somebody attempt to defend the opposite assignment? It's just stupid. Why would you defend a nonsense about how it matters how much something moves when know that you can see visible motion, when all you need to know is it's a constant force? If it's a constant force, the answer's already given to you. There's no way to escape a constant force. If the energy isn't in the object moving it, then it's in the thing stopping it from moving. Duh.